In this series of videos, we're going to review some concepts that you focused on in your Mass and Energy Balances 2 course. And we'll begin by discussing and redefining energy. As you may, to give you a precise definition, energy is the capacity to do work. As you may remember from MEP2, energy is synonymous with effort. To give an example, if you want to do your homework, you need to exert some sort of effort, and energy is the capacity to exert that effort. And so when we talk about energy, it's always important to think about the first law of thermodynamics. And according to that first law of thermodynamics, we know that energy is conserved. But we have to be a little bit careful when we say this, because when we're talking about the conservation of energy, we're not talking about a specific system. Right? The energy within a system can change. What we're actually talking about is that energy is conserved in the universe. Right? And so the first law of thermodynamics is specifically referring to the combination of some sort of system plus its surroundings. And so the system and surroundings would make up the universe. Okay, and so let's visualize this a bit. So let's say we have some sort of system here in blue, and the borders of the system are these dashed lines. Everything outside of the borders are what we would call the surroundings. And let's say in this scenario that we have energy that leaves the system and goes into the surroundings. And so based on at least this scenario, we could say that the change in energy of the system is going to be negative, right? Because energy is leaving the system and going to the surroundings. Conversely, we could say that for the surroundings, the change in energy is going to be positive because it's receiving energy from the system and it's going to the surroundings. But based on the first law of thermodynamics, we know that the change of energy of the system plus the change of energy of the surroundings need to be balanced out. And if you add these two delta E's together, they would sum up exactly to 0. All right? And so that's what the first law of thermodynamics is telling us. Now, the transfer of energy between the system and surroundings and vice versa, that occurs either through two different mechanisms, or two broad mechanisms. And so energy transfer between the system and surroundings occurs via heat, which we'll abbreviate as Q, and or work, which we'll abbreviate as W. Okay? And to be consistent with what you learned in MAB1, or the convention that you used in MAB1, when we talk about heat and work in this class, we're going to define them so that their values are going to be positive if they flow from the surroundings to the system, and if the opposite happens, if they flow from the system to the surroundings, they're going to be negative. So negative if the flow from system to surroundings. So like we said in the scenario up above, our energy, which we could say perhaps there was some sort of heat transfer going on, because that heat is leaving the system to the surroundings, that means our Q value would be negative here.